Here we are with Unit 4, Lesson 8, homework help. Let's get started. Number 1, Lynn is looking at the equation 2 times x minus 32 plus 4 times the difference of 3x and 2,462 is equal to 14x. She says, I can tell right away there are no solutions because on the left side you will have 2 times x plus 12 times x and a bunch of constants, but you have just 14x on the right side. Complete the statement about whether you agree with Lynn. What we need to do, always, step 1, always is simplify. We want to make sure that we simplify because we need to compare constants and we need to compare coefficients of x. So twice the value of x minus 32 plus 4 times 3x is 12 times x. And then 4 times 2,000, let's see here, we're going to go 4 times 2,462 is 9,848. I know that that's a negative times a positive. So 9,848 is equal to 14 times x. Okay, awesome. Now I need to combine my like terms. I have the x right here and the x right here. Combining those together gives me 14 times x. And then the negative 32 with the negative 9,848. Let's go ahead and put those in there. Negative 32 minus, 32 minus 9,848 is equal to negative 9,880. Now here's the part where now that I'm simplified, what I can find out here, what we can do with this, we can take it a step further if you'd like, to find out, is this really no solution? What we're comparing, I see first off that the 14x, the coefficients of x are the exact same, but there's no constants that are same. This one is effectively plus 0 on this side. And so what happens is when I subtract the 14 times x, to eliminate it from one side, what happens is I end up eliminating it from both sides, leaving the statement as 9,880 is equal to 0. That is 100% false. So what does that mean? Well, that means that, yes, I agree with Lynn that I can tell right away the solutions on the left side is 14 times x and 14 times x, but you have a bunch of constants on one side. Her logic is a little bit lacking, but for what it is, it's pretty good because I can agree with Lynn that there is no solution. She did do a little bit of simplifying right here. Whoops, I didn't mean to highlight all that, but she did a little simplifying right there. But this bunch of constants business, she could have said that a little bit better. The fact is this, if I were to go in there and say that the constant terms on the left side are negative, that's true. So they cancel or will cancel to 0 or will not cancel to 0. Well, they're negative, but the question is, what do we mean by canceling them to 0? The fact is this, they are not equal to each other, just not equal to each other. Never will be, never ever will be. So we're not going to see 0 equals 0. We're always going to see that this statement is false. So agree with Lynn, but know that this is no solution. So here's Han. He's doing the same thing. This is Prince Han of the Northern Lands. We have Han was looking at the equation 6 times x minus 4 plus twice the value of the sum of 5x and 2 is equal to 16 times x. He said, I can tell right away there's no solution because on the left side, you'll have 6 times x plus 10x and a bunch of constants. But you have just 16x on the right side. So basically, he's copying Lynn and trying to get away with the same thing. Complete the statement. Well, what we told Lynn, or what we did before, was we simplified. So we simplify again, 6 times x minus 4 plus 2 times 5x is 10 times x, and 2 times 2 is 4, is equal to 16 times x. When I use the commutative property to combine like terms, I get 6x plus 10x minus 4 plus 4 is equal to 16 times x. And I see a little issue right here. This is 16 times x, but I see that a negative 4 plus 4 is actually a 0 pair. So really what I have is 16 times x is equal to 16 times x, which tells me Han's wrong. I don't agree with Han. because the left side and the right side of the equation are equal or not equal, which means the equation has all solution, one solution, or no solution. Please select the appropriate choices and join me on problem number 3. Problem number 3 says to tell us whether each equation is true for all, one or none. So again, this is just reiterating what we did. Simplify first, compare the coefficient of x, then compare the constant. Same coefficients, like right here, 6 and 6, would tell me that these values are going to have the same products. And after I find that product, I would subtract 4 on the left and subtract 4 on the right. What does that tell me? That tells me that all of my solutions are going to be correct, no matter what. Because these two expressions, even though they're written a little bit different from each other, they mean the exact same thing. Okay, looking at the next one, I have a product of 4 times x and a product of 4 times x. But here on the left, I'm subtracting 4, while on the right, I'm adding 3. Those products can never, ever equal the same thing, because the product on the left, I'm taking away values, but on the right, I'm adding to them. It will never, ever be balanced. This one is always going to be false for no solution. And then finally, the last one. Here's the thing that I love about this last one. I see my coefficient of x is different. That means that what happens is when I go ahead and I get rid of one of those values, or when I use a property of equality, I'm going to add 3x here and add 3 times x here. What happens is I'm still left with a positive 1 times x. Even though at the very end of this, I'm left with this, and I subtract 4 and I subtract 4, the bottom line is this: x equals 0. That is a solution. That is a solution. It doesn't mean that there's no solutions. It means that the solution is x equals 0. That means 2 times 0 is 0 plus 4, and negative 3 times 0 is 0 plus 4, and 0 plus 4 is the same thing as 0 plus 4, which means x equals 0 is my accurate and complete and correct answer. So there's only one and only one solution, and that is 0. Next question, 4, 2 parts, A and B. For part A, it says complete the statement that best describes how to solve this equation. Now, what they've done with this is they've kind of stuck us into a certain route, so you have to look and see what they did. If you remember back to the lesson, we saw some things with fractions. What would I do with this one with 1/3? Would I multiply both sides by 1/3 or divide by 1/3? Keep in mind this is 1/3. What I have shown you in the lesson is that I divided by 3. So what is divided by 3 is more like, is dividing by 3 multiplying by 1/3, or is it dividing by 1/3? Think about what this means here. Am I multiplying by 1/3 or dividing by 1/3? And then what would I do with the 5? Then I would have to, it shows a negative here, I would have to add 5. I want you to think about why we did this and what the steps were. Okay, if I were to distribute it, that would be a different thing. At the very end, I would multiply or divide by 3, which hopefully I'm just going to tell you, we want to multiply by 1/3. So what is the solution for this? Well, 3 times x minus 5 equals 6. When I divide by 3, it's the exact same thing as multiplying by 1/3 and multiplying by 1/3. 1/3 of 3 is 1, and 1 times x minus 5 is equal to 1/3 of 6, which is 2, which gives us x minus 5 is equal to 2, and I'm going to leave you to solve the rest of that. This is a little bit of review going back to number 4. Part B, get the answer right in here. Do not include the x, just put whatever your number is going to be right there. Okay, click in the box and put in your number. Number 5 is working on something very similar. Complete the statement that describes how to solve. Again, this one is on your own. I'm not going to do this one for you, but I want you to think about the thing. What would I do with the 1/2, especially considering right here what I've shown you is to divide by 2. What do we mean by divide by 2? Is that multiplying by 1/2 or dividing by 1/2? And then what would you do with the 2/3? And then solve it and give me an answer. Number 6. Same type of situation. Okay, but I think this one's probably a little bit easier. What would you do with this equation? I would add x or I would subtract x. Which would it be? They're talking about this value right there for both sides, and then select what you would do with 1/5 to be able to get this figured out a little bit later down there. And then solve the answer. It does kind of put you in a spot where you have to know what we're talking about or which piece is like a certain direction to go with it, but I know you can do it. Number 7 goes back to unit 3. The points -2, 0 and 0, -6 are each on the graph of a linear equation, so they're on one single line. Complete the statement about whether the point 2, 6 is also on the same graph. How do I do this? Well, what we need to think about first is what is the slope, and then what is the equation for this? Remember how we found the slope, we found the y-intercept, and we could write the equation? So what we're going for is we need to know what this equation is. And then once we know what it is, we can substitute this into here to decide if it's true or not. So remember, we have to find the slope first. What I've seen a lot of people doing lately is putting it into a table and seeing that we're going 0, -6, and -2, 0. And I think what's really cool about this is we're working off of it from 0 or -6 to 0 is increasing by 6, whereas on y is decreasing by, or excuse me, on x is decreasing by 2. And then we create our slope ratio, which is 6 divided by -2, or m equals -3. We've just figured out what would go right here, -3. Now, these lovely people here, they actually gave us a little hint. They gave us the y-intercept. So what I know now is y is equal to -3, the slope that I found, minus 3, or -3 times x minus 6, because that's my y-intercept. And now I need to know if this point, if 2, 6, is going to work for this. So the -3 and the 6 are both constant values. One is a constant rate, one is a constant value. And now I need to plug in my y and my x. In this case, y is 6 and x is 2. And I need to see if this makes a true statement. If this is true, then we would say the point is on the line. If this is false, then we would say the point is not on the line. So finish the math to figure that one out, and then join me on the next problem, problem 8. Where we have a couple triangles, we get way back to unit 1. In this picture, triangles A prime, or triangle A prime, B prime, C prime is an image of triangle ABC after a rotation. The center of rotation is E. What is the length of side AB? Well, I would tell you to remember what happens when we rotate from here, the length of this segment, to here. We see that segment A prime, B prime is 9 units long. So how long was it before it was rotated? What is the measurement of angle D? So angle D right here, it was 45 degrees. What is it after it was rotated? And then finally, do rotations preserve side lengths and angle measures? Type yes or no. And then once you've done that, hit done and review. Then make sure you submit your work, and you're fantastic, and you did a great job on your homework. Nice job, and I hope you have a great day.